All right, welcome back to your online geometry course. We have obviously already finished the first section, which was 1.2. I hope you guys have gone and completed the homework for 1.2 in MathXL to make sure you've mastered those skills before we move on. A lot of these skills, like other math classes, build on previously learned information. So, if you've not done that homework, you might want to stop and go back and try those problems before moving on to here. So, we are doing 1.3. 1.3 is going to be more geometry basics. I've already come up with a description of what a line segment is. I want to jot that down again. You guys probably remember that it is a part of a line consisting of two endpoints and all points in between. Just remember that a line segment and a line have no thickness. So, a line segment. Here is an example of a line segment. A, B. Now, if I wanted to talk about a line segment using notation, I could write out segment AB. That's one way to do it, but you have to write words out, and I'm a mathematician, so I'm lazy, crazy, and efficient. The real notation that we use is AB with a line segment over top. Notice there are no arrows. If there are arrows, then it would be line AB. This is the same thing as line segment BA. Okay, those are the same thing. It's just where does it start and where does it end? That's what a line segment is. Okay. Now, the length of a line segment is the distance between, that means between endpoints of a segment. Okay. So let's say up here that had a length of 5 units. All right. Once again, we could write out the words, the line segment's length is 5, or line segment AB has a length of 5. Mathematicians, crazy, lazy, and efficient, they look at this and they say, okay, so this is how we denote the actual object itself. I say, yes. Okay, well, how can we note that the length is 5? Well, the easiest way, and what they decided on, was just don't put the line segment on top. If I say BA equals 5, that means the length of line segment BA equals 5. With the line segment on top, it's talking about the object. Without the line segment on top, it's talking about the length of it. All right? All right, let's keep cranking along here. Some of the things that we learn in geometry you think are such common sense that you wouldn't even have to write them down. Remember, we talked about this word postulate. Postulate is just something super, super basic. It says if three points A, B, and C are collinear and C is in between A, B, then what do we know? You're going to think this is silly that we're even going to write this down. Here is A, here is B, C is somewhere in between. Let's see. Okay. Well, what do we know? Well, we know that AB, the length of AB, is going to equal AC plus CB. All that's saying is that the whole line segment is equal to its parts together. That's common sense. Something is made of all of its parts all together. The United States is all of these states together. Well, that's a little bit confusing because technically we have Puerto Rico and Guam or something like that. But anyways, this is just some object is equal to both of its parts together. So if this was 2 and this was 5, then all of AB would be the two parts together, 7. Once again, it seems so basic that we wouldn't even have to write it down, but we do. All right, let's keep on cranking. Grab this, scroll up. Okay, so you're going to have things like this. Mn contains point J. Mn is 59, Mj is 8x minus 14, and Jn equals 4x plus 1. Then what does x equal? All right, the key to being successful in geometry is to make sure you draw out what they're talking about. So here I have no idea what they're saying, so I'm just going to draw it out. I go in, I say, I got to click on pencil. Okay, so once again, they said if you have m going all the way to n, m going all the way to n, okay, and j is going to be somewhere in between. If they don't tell me that it's perfectly in the middle, do not draw it perfectly in the middle. You never want to get more specific than what they tell you. If they don't say it's in the middle, then just put it somewhere else. Okay, so let's say this one right here is where j is. Okay, if you put it in the middle, you're going to assume that each side is equal, but it's not. Then they tell you mn equals 59. So what I'm going to do is note this. mn equals 59. Great. And then it says mj is 8x minus 14. Sorry, that doesn't look very good. And then over here, this is going to be, it says Jn is 4x plus 1. So how are we going to do this problem using the postulate we just learned? Well, we learned that a part plus a part equals the whole. So if I wanted to write this out, we know that mj plus jn equals mn. Does everybody agree that the part plus the part equals the whole? Yes, you should say yes. Well, then let's just put in what mj is. Mj has a length of 8x minus 14 plus whatever jn is. Jn is 4x plus 1, and that equals the whole length, which is 59. Look, like I told you guys, we sprinkle algebra into geometry. Okay, so what are we doing here? We're making sure that you know how to combine like terms. Minus 13 equals 59. Make sure I'm doing this right. Yep. Okay, then what do? We are going to add 13 and add 13. So you get 12x equals 13. We're going to add 13 to the side. That's 62, 72. And when you divide by 12, you get 6. Okay, so since it asked what x equals 6. Okay, hopefully that made sense for you. What I want you guys to do is work out the next problem. You can pause the video and work out the problem, and then you're going to check your answer. Okay, and I'm going to pause the video and make the question for you, so you're going to have to answer it before you move on. Give this a shot. Draw out KM, note all the stuff, just like I did up here. All right, hopefully you have paused the video and you've come back. I'm going to work through it, but you are going to add the answer in Edpuzzle before we move on. So we have KM. K is here, M is here. They say G is somewhere in there. Did it say the center? No, so don't go over and make it perfectly in the center. They say KG is 3x plus 2. They say that GM is 2x minus 3. And they say that KM, this whole entire length, is equal to 4x plus 10. Okay, so we can go over and say part plus part equals whole. Part is 3x plus 2 plus the other part, which is 2x minus 3. That equals the whole, which is 4x plus 2. Together, those gives us 5x minus 1 equals 4x plus 10. Subtract 4x, you get x. Add 1, you get 11. Now, this is the confusing part. Did it ask what x was? No, it wanted to know what km was. So if x is 11 and km was this, then you would say 4 times 11 plus 10. It gives you 44 plus 10, which is 54. That's your actual final answer. You don't want to lose 1 point for forgetting to substitute it back in. All right, hopefully that made sense. Let's keep on cranking along. Okay, more definitions. Okay, we have this word congruent. We don't use the word same in geometry. We use the words congruent and equal. Congruent means identical in form. Identical in form. Sorry that this doesn't look very neat. Identical in form. It doesn't say it has to be the same color. It doesn't have to be oriented the same. Let's say we had a Ford F-150 pickup truck, and then we had another Ford F1 pickup truck, and they were the same year, the same model, everything, but one was blue and one was red. Would they be congruent? Are the objects congruent? Yes, they are. You can change the color, but they're identical in form. Okay? So let me show you one. Let's say this was AB and it had a length of 4, and this was CD and it had a length of 4. Sorry, I didn't draw it perfectly. Are those things congruent? Are they identical in form? Yes, they are, because they are both 4. So here is the notation you use. You would say line segment AB, not the length, but the actual line segment. This is your symbol for congruent. It's an equal sign with a little wormy thing on top. AB is congruent to CD. Ta-da! Now let's say that we had a line segment on a drawing and we had another line segment and we wanted to say they were congruent, but we didn't want to write this out. You can use a 1 tick mark and 1 tick mark, and that means that those things are congruent. If you had 2 other things that are congruent, you would do 2 tick marks and 2 tick marks. And that's the same thing, saying that they are identical in form. They are congruent. Okay? Okay. Next, the word equal is the word we use when they have the same measure. Have same measure. And yes, I do realize I just said don't use the word same, but it's hard to do a description without using the word same. They have the same measure. So that means if you had this and that was, those two things are congruent, this you would say AB equals CD. This one you use for the actual object, and this is for a measure. So let me go over that. With the whole Ford F-150 thing, the truck, the two trucks themselves are congruent. Their weights are equal. Their lengths are equal. Anything that you can measure, we use the word equal. When we're talking about the objects, it's congruent. Okay? If I had 2 desks in our class and they looked exactly the same, but one was a different color and one was rotated, but they are identical in form, the objects themselves are congruent. Their weights are equal. Their measures are equal. So just make sure you know when to use congruent, when to use equal. Right? There you go. That's an example right there. Okay, next. A midpoint is a point that divides a segment into 2 congruent segments. Okay, so let me show you that. Here, let's say we had a line segment AB, and we wanted to have a point right in the middle that was perfectly in the middle, the midpoint. Let's say C was a midpoint. The way I show it's a midpoint, remember, if that has 1 tick and this has 1 tick, it means that is the same exact length as that. That means that this must be the midpoint because it makes 2 congruent segments. It divides the segment into 2 congruent segments. So that is what a midpoint is. You have to put the tick marks there. Now, the nice thing is if you actually measured this in millimeters and measured that in millimeters, they would not be the same. But since I put a tick mark and a tick mark, I already know that they are definitely congruent. Okay. Now, a segment bisector is a ray, segment, or line that goes through the midpoint. I'm going to say MP for midpoint. So let's say you had this line segment right here and you wanted to show something that was a bisector. You see how this goes through its midpoint? This thing right here is called a segment bisector. Bi means two. Sector means cut, I think. I don't know. Ask Mrs. Rudabush. Bisector. So segment bisector cuts the segment through its center. All right? That's what a segment bisector is. Let's keep on cranking. Just make sure you guys know the notation. Make sure if you're talking about two objects, you use congruent. If you're talking about their measure, you use equal. Let's say you had two sandwiches that were identical in form. Everything was exactly I know I shouldn't use the word, but same. The objects would be congruent. Their weights would be equal. Their areas would be equal. Okay, let's keep on cranking. So let's do another one here. This one has to do with midpoints though. So on this one right here, it says Mn contains J such that Mj equals Jn, or is congruent to. Oh, that means it's the midpoint. So draw it out. Everything in geometry you want to draw out if you can. Mn contains J such that it's the midpoint. Tink. Now Mj is going to be 6x minus 7 and Jn is going to be 5x plus 1. You need to think in geometry. Don't just do stuff. So like some people would be like, oh, we added these before. Let's just add them now. What would that be? A part plus part equals the whole. Do we know what the whole is? No, so that makes no sense. What do we know? That thing is congruent to that. When things are congruent, you can set them equal to one another. Okay, so that means that 6x minus 7 must equal 5x plus 1. Minus 5x gives me x plus 7 equals 8. Does it just ask for x? Sure does. Just ask for x. So that means we don't have to substitute it back in. Do not just go on a method of, oh, you always add them together. You have to think in geometry. You have to think, are these things congruent? If they are, then I could set them equal to one another. Are they giving me a part and a part, and I can set equal to the whole? Okay. All right. On this one right here is a little bit trickier. It says the midpoint of Mn. P is the midpoint of Mn. Let me draw this. Mn. Mn. P is the midpoint. Oh, that's not perfect, but if I put tick marks, I know that it's the midpoint. M is at negative 12, N is at 2. Where is P? Well, it's got to be halfway from here to here. Going from negative 12 on a number line, you'd walk 12 steps to get to 0. Wait a second. Yeah, you'd walk 12 steps to get to 0, and then you would walk another 2 steps. So this total length is how far? That total length is going to be 14. So what is half of that? 7. So where is this? It's going to be 7 away from that or 7 away from there. If we started at 2 and went backwards by 7, where would we end up at? Negative 5. Okay, let's keep on cranking. Page next. Okay. Now options, stroke 1. Cool. Okay, some of these are a little bit more challenging. Ugh, there we go. Okay, let's grab and pull. Okay, let's go ahead and run through a few of these. Some of these are a little bit harder than others. So this one says TU, make sure, I don't like that. Hang on, I just have to change stroke size to strange to 1. Okay, TU has M at its midpoint. So let's draw that. TU has M at its midpoint. Okay, if T is located at negative 4 on a number line and U is to the right of T, which I drew it like that, great, and Tm is 8x plus 11, and Mu is 12x minus 1, where is U located? Shenanigans. Well, they told us it was a midpoint, so I better put these tick marks. Like I said, geometry is a thinking class. Is there anything we can do? I have no idea how to do this problem completely, but is there anything we can do? Yeah, since that's a midpoint, then those must be congruent. So I can set those things equal to one another. Let's go ahead and do that. 8x plus 11 equals 12x minus 1. Let's go ahead and solve it. Minus 8x minus x is 4x, plus 1 is 12. Therefore, x equals 3. That's not the answer. That's not what they're asking for. They want to know where u is. Well, what could I do? The only thing I could really do is substitute this into here, or into here. I'm going to substitute into this one. 12 times 3 minus 1. 36 minus 1 is 35. So I know that this length here is 35. Is there anything else that I can say? Yeah, this one is also going to be 35. So the whole length is 70. If we started at -4 and we went 70 in that direction, where would we end up at? 66. Lovely. So as you can see, you've got to think in geometry. There is no just like, oh, just do the same exact steps as I taught you. You actually have to think, do I have two things that I know are congruent, meaning can I set them equal to one another? Do I have two parts that can equal a whole? Do I need to substitute a value back in? You got to think through all these things. Next one says MN intersects AB at its midpoint. So let's go ahead and do that. AB, here's its midpoint, K, and MN goes through it. MN. And I'm going to put congruent marks because they tell me that. AK is 3x plus 10. KB is 46. I want you to think about how to do this problem. What are you going to do? Are you adding parts to equal a whole, or do you know things are congruent? Go ahead and do that problem. Well, you should know that since this is the midpoint, those are congruent, so I can say 3x plus 10 equals 46, which means 3x equals 36, which means x equals 12. Okay? Do we have to substitute it back in it, or did they just ask for x? They just asked for x. Okay, let's go ahead and I'm going to do one more problem. So it says MN intersects KL. They both bisect one another, meaning one cuts the other in half, but the other cuts that in half as well. They intersect at 90 degrees. Angle at P. Okay, I'm going to try to draw this. So MN is going to be cut in half by this other KL. And it says that they intersect at 90 degrees. Not only that, but this is congruent to this, and that's congruent to that, because they say they bisect one another. Now, it says it intersects at P. All right, if KP equals 3 and MP equals 3x plus 1 and Pn equals 4x, then what is the distance between, what the heck? What is the distance between M and K? I have no idea. So you would want to look at these problems and say, what do I know? Is there anything I can do? Well, since this is a midpoint, those must be congruent. So I know that 3x plus 1 must equal 4x. Right? Okay, let's just run with that. If I solve this, minus 3x, you get x equals 1. Great. Also, if that is 3, then this must be 3 up here, because those are congruent. Is there anything what do you guys think we should do with this 1? Okay. Oh yeah, we always substitute them in. So this could be 3 times 1 plus 1, which is 4. Let's just zoom in on the part that we're talking about. It's basically a right triangle where this is 4 and this is 3, and they're saying, what's that? Does anybody remember how you find the third side of a right triangle? Pythagorean theorem. 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. 5 equals x squared. And you get 5. That would have been a really hard problem. Okay, you just set it up, do everything you can. If all you can do is write down, draw it out, just do that and see if you can grab a handhold. Treat it like climbing. I don't know if any of you guys climb, but you're always trying to plan your route out. But usually, sometimes you'll like pull, you'll be rock climbing, and then you find a handhold and you grab onto it and you pull yourself up and see if you can go anywhere from there. If you can't, come back down and try to go a different route. But if nothing else, set things up and see if it spurs your imagination of what you should do. Okay. On this one, it says relate two objects. I guess we could finish really quickly. Two objects using the words congruent and equal. Two identical cups would be congruent. Their volumes would be equal. Just make sure you use the word congruent. I'll write this down. Congruent. Congruent is that. That is the actual object. It's a big pet peeve of me when you guys accidentally switch these words. The measures are equal. Let's say I had a perfect identical twin. Then me and my twin would be congruent, and our weights would be equal. Our heights would be equal. Our arm span would be equal. Anything that you can measure is equal. The object themselves are congruent. All right, I hope that that lesson made sense to you. Just make sure you guys know your notation. Make sure you know when you do the line segment on top and when you don't. And the biggest thing is, even if you can't do the whole problem, you want to set up part of it. Set it up, and maybe that'll spark your interest. Also, do not just go based off of what you've done before. Don't go, oh, well, I always add them together. You only really want to add them together when you know what the whole is. If you know something's a midpoint or they're congruent, then you can set them equal to one another. Thank you much for watching the video.